But the types of equations that we see today are going to be called something different. It's a different type. So this is 5-3 part 3. There you go. And the directions kind of tell you what these equations are called. It says solve the multiple angle equation. Solve the multiple angle equation. And I'll show you, once I put the first one up here, I'll show you what makes it multiple angle. There is a big difference. And we're probably going to use handy dandy again if you want to grab yours. Still kind of using that table at the bottom to help us find our solutions. Very nice. Here we go. Example 1. Sine of 2x equals negative 1/2. Sine of 2x equals negative 1/2. Here's what makes this a multiple angle equation. The part that's with the sign right here is not just x, it's 2x. That's something that we've never seen before. And so that is what classifies this as a multiple angle equation. I can't remember on tests and quizzes for sure if I tell you in the directions that it's multiple angle. So that's why I'm going through this right now, so you can see it for yourself. If I see something with x, it's not just x, something with it, that's what makes it multiple angle. And we have to do them just a little bit differently. Okay? Well, anytime you learn something new in math, you try to compare it back to something that you already know how to do. Like with the factoring stuff yesterday, I was showing you how we factored with x's so we could do it the same way. Let's take this for a second, and I would put all of this in my notes because this is going to be really helpful. And let's just think for a minute. If the 2 wasn't there, what if it said just sine of x equals negative 1/2? If the 2 wasn't there and it was just sine of x equals negative 1/2, then I would pull out handy dandy and I would look at the sine row and I would scan the sine row for all of the negative 1/2s. And I'm going to do that right now. I see them at 7 pi over 6 and 11 pi over 6. I put the word or in the middle. You don't really have to use the word or. You could even put and or put a little comma like you're listing them out. But that's what x would have to be if sine of x was negative 1/2. Well, for us, we don't want x to be negative 1/2. We want 2x, sine of 2x, to be negative 1/2. And so to kind of change this into what we need, instead of writing this as x equals 7 pi over 6 and 11 pi over 6, let's change the x to 2x, because that's what we actually have in this problem. Again, we don't want sine of x, we want sine of 2x to be negative 1/2. Now, once you get going with these, you may not really have to write out these steps initially on every problem, but here's how we finish it. We pretty well use these numbers to set up different equations. On one of my equations, I want 2x to equal 7 pi over 6. And on the other equation, I want 2x to equal 11 pi over 6. I'm just breaking those apart again to use both of those numbers that I got on handy dandy. Now, in general, when you're solving an equation, and your variable is being multiplied by 2, how do you undo that? Divide by 2. That's what we're going to do on both sides. Now this, I realize, looks a little wacky because it's a fraction and I put like another division symbol under it. So you can do the keep, change, flip idea, or if you think about dividing by 2, when you divide by something, it's the same as multiplying by the reciprocal. So I'm not really going to think of it like that. I'm going to think of it as multiplying by 1/2. So 7 pi times 1 is 7 pi, and 6 times 2 is 12. So one of our solutions is 7 pi over 12, not 7 pi over 6. That was when it was just x. Now on this side, I mean, it's the same first step. You still need to divide by 2 to get rid of the 2. And here again, dividing by 2 is like multiplying by 1/2. So this would be 11 pi over 12. That is our second solution. So just to summarize, use handy dandy first, like you would if it was just x. Figure out what those numbers are. And once you find those numbers, set whatever that was. It's not always going to be 2x. It could be a different number out front. But set that equal to those numbers and then just solve for x. Okie doke. Let's keep going a little bit and then I'll see if you have any questions. Example 2, cotangent of x divided by 3 equals 1. This part right here again is the reason it's a multiple angle. Now that sounds weird because x is being divided by 3. Why would they call it multiple if they're dividing? Well, dividing by 3 is like multiplying by 1/3, so I guess if you want to think of it like that, you can. It is a multiple angle. So imagine what you would do if it was just cotangent of x equals 1. Anybody see where cotangent of x is 1? And 5 pi over 4. Very nice. That's just for x though. We want x over 3. So you've maybe already gone through and separated this out. I still kind of have it together. We need to take x over 3 and set it equal to pi over 4. And take x over 3 and set it equal to 5 pi over 4. Now, thinking about how to solve for x, x is being divided by 3, so to undo that, we'll have to multiply both sides by 3. And if you want to think of it as 3 over 1, you can. So that turns into 3 pi over 4. On this side, multiply by 3. And again, you can put that over 1 if you want. So that turns into 15 pi over 4. Those two are our solutions. Okie doke. Multiple angle. When what you have is not just x, it's something multiplied by x. Technically, that's a 1/3. All right, any questions so far? I think I've just got a couple more. Now, this one has a square in it. I don't think you have any square problems in your homework, but that doesn't mean they won't show up later on a test or a quiz. So watch carefully. It says tangent squared of 4x equals 3. You don't have to write this step out if you don't want to, but I do want you to remember that tangent squared of 4x, that's the same as the entire tangent of 4x squared. And so what do we need to do to get rid of the square? Square root. Now on the PowerPoint, I just did it right off the bat there. You can go ahead and write this step first if you want. But either way, square root both sides. It gets rid of the square. Now make sure you don't touch anything else. The 4x does not change when you square root that. It's just going to cancel out with the square. And looky here, I did square root both sides, so I have to put plus or minus square root of 3. Now, it's not just x, it's 4x. That is what makes it a multiple angle. So imagine what you would do if it was just tangent of x equals plus or minus square root of 3. The plus or minus is going to add to our list a little bit. That would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. There are 4 options up there, but again, we don't want x to be those numbers. We want 4x to be those numbers. And so you've maybe already done the separating, but 4x gets equal to pi over 3. It's also equal to 2 pi over 3, and 4 pi over 3, and 5 pi over 3. So x on all of those is being multiplied by 4, which means we have to divide by 4. And here again, it looks wacky, but dividing by 4 is the same as multiplying by 1/4. That turns into pi over 12. Now I do need to show you something, I think, with this next one. When you multiply this by 1/4, you would start with 2 pi over 12. But you can reduce that. If you divide by 2 on top and bottom, that actually needs to turn into pi over 6. So keep a lookout for any fractions that can be reduced. So pi over 6 for that. I think you can do a little bit of reducing on the next one. Divide by 4, and you could even think about just crossing those 4s out. That just turns into pi over 3. And last one, multiply by 1/4. You can't reduce that. It would just be 5 pi over 12. 4 solutions. You always have quite a few anytime you've got that plus or minus. Any questions on number 3? All right. There's only one more. This is a fairly short lesson here. Once you see how the first one's done, a lot of them just kind of work the same way. So, everybody good with that slide before I move on? Okay, number 4, slight difference on this one. 2 cosine squared of x over 2 equals 1. 2 cosine squared of x over 2 equals 1. The slight difference that I was talking about was, it's almost the very same type of problem except for the number in front. We didn't have a number in front on number 3. So instead of square rooting both sides right off the bat, I kind of like to divide by 2 on both sides first. It always helps if you get the squared part by itself before you square root, because that just makes sense. You want the square and the square root to cancel. So you kind of need to get that part by itself first. Now, when I square root both sides, the square is gone, and it's just cosine of x over 2. And look at you, square root of 1/2. I need to make you look a little bit better. So think about the square root of the top and bottom separately. Now top part works out pretty nice. That is just 1. But we can't leave that square root of 2 on bottom. So multiply by square root of 2 on top and bottom. And don't forget the plus or minus. That tells us cosine of x over 2 equals plus or minus square root of 2 over 2. Here again, it's not just x. It's x over 2, or you can think of that as 1/2 times x. It's a multiple angle equation. So first of all, I want to look at handy dandy and search for where cosine is positive square root of 2 over 2 or negative. There's 4 options there. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. But we don't want x to be those numbers. We need x over 2 to be those numbers. So set it equal to pi over 4, equal to 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so what am I going to have to do on all of these to get x by itself? Yep, multiply everything by 2. Now you will have to reduce 2 pi over 4. You can put that over 1 if you want. That would reduce to just pi over 2. Then the second part, multiply by 2, you get 6 pi over 4. But divide by 2 on top and bottom, that would be 3 pi over 2. Multiply by 2 right here, I get 10 pi over 4, but that reduces to 5 pi over 2. Then, last one, 14 pi over 4, that can be reduced to 7 pi over 2. Okie doke. Again, it's multiple angle when it's not just x. There's something else going on with the x. Any questions about those? That's the last part of 5-3. So the homework assignment is pretty short. I'm pretty sure you can get this done in class. There are no squared problems for some reason in the book. But remember, those could come back on a test or a quiz. We are just doing 61 to 68 from page 374.